Welcome to my presentation on magnetic levitation. First, we're going to discuss the two types of magnetism, which are paramagnetism and diamagnetism. Now, diamagnetism results from having no unpaired electrons within an atom, whereas paramagnetism results from having at least one unpaired electron within an atom. These two differences cause variations in a material's properties with regards to magnetism and magnetic fields. Diamagnetic objects are very weakly repelled from magnets, whereas paramagnetic objects are attracted to them, and the field lines bend away from diamagnetic objects, whereas they bend towards paramagnetic objects. We're going to explore the effects of this in this presentation. Now, as we know, there are certain objects in this world that we observe to be magnetic and certain ones that are not magnetic. Namely, metals are magnetic, and organic materials, wood, plants, and people are not magnetic. However, this isn't exactly true. All things are made up of atoms which have electrons spinning around them in molecular orbitals. These electrons carry a negative charge, and due to the fact that changing electric field will create magnetic charges or magnetic fields, they would indeed have magnetic fields. However, due to the fact that the electrons are spinning in random orbitals, these charges usually cancel themselves out, resulting in a net charge of zero. However, when placed between an existing magnetic field, these electrons align themselves properly to form a magnetic force which opposes that existing magnetic field. And this can be applied to result in levitation. This was discovered first in the 1930s by a German physicist named Werner Brombeck. He placed samples of lead and bismuth between two magnets, creating this magnetic field and aligning their electrons and causing these samples to levitate. Unfortunately, his work and research was lost and forgotten about for about 50 years. However, he used this equation to provide his experimental results, where the left side of the equation describes the magnetic field properties, and the right side describes the properties of the object in between the field that is going to be levitated. Now, you see that the P stands for the density, and the X is the magnetic susceptibility of that certain object. The G and the U naught are the gravitational acceleration and the permeability of free space. When all multiplied up correctly, this will give you the strength of magnetic field required to levitate a certain object. This was shown later in the Netherlands by researchers who were able to levitate a frog within a 32 millimeter diameter solenoid and a magnetic field of about 16 teslas. Now, this is super cool, watching this frog float around within a solenoid without any other forces besides magnetism. You can see that he's being repelled by the walls and floated around. What's cool about this is the effects of this magnetic field are actually minimal. The frog was able to walk out without any harm done to him, meaning that this technology could be used for further research and exploration, especially within the field of zero gravity. Now, if you wanted to make yourself float in the same type of solenoid, it is possible, however not very probable, and not going to be happening anytime soon, because it would require a magnet of about 45 teslas, and you would need 1 gigawatt of continuous power consumption just to operate the instruments. And just for those who don't know, 45 teslas is actually the strongest magnet in the world right now. So it's not exactly something available to everybody. So while it's not exactly probable right now, it is possible. But it can still be used for the zero gravity research. Researchers in the University of Nottingham were able to do the exact same experiment using fruit flies and examine the effects of this zero gravity field. Those flies that were subjected to the zero gravity solenoid were able to actually come out walking at 2 times the speed of those that were not, which is consistent with the experiments done by NASA in the space stations. This proving the fact that they can do the same research here on Earth instead of having to send people and materials up into space to do this research. This is valuable information because it will save massive amounts of time, money, and effort in this zero gravity research, making it more available to be done and further progression to be advanced. This These properties can also be used in the implementation of transportation. The first maglev train was installed in England and other ones have also been installed in Eastern Asia. These trains travel using only the effects of magnetic levitation and propulsion, thus creating a train without any friction other than the normal standard friction in air. These trains are capable of traveling at around 375 miles per hour. That means you could travel from New York City to Los Angeles in only 7 hours. These trains also are operated completely by computer programs remotely, meaning there's no need for a driver, which would create more flexible travel schedules and would reduce crashes and derailings, increasing safety. This is incredible, how using only the powers of magnets to repel um, and push a train, you can travel across the country in no time. Now, these are not the only implications, but these are the two big ones that are being talked about in the scientific community today. Thank you for watching my presentation. Hope you have a wonderful day.